So it's a great pleasure to welcome Dr. Nawamin Pinpathomrat from Thailand. So Nawamin is a lecturer at the Department of Biomedical Science, Medicine at Prince Songkla University in Thailand. He did his DPhil, his PhD, at the Jenner Institute at the university here in Oxford on preclinical development of a viral vector tuberculosis vaccine. One interesting fact that you may or may not know is that Nawamin actually in the last year of his DPhil unexpectedly ended up being a MasterChef UK finalist in 2018. So do check out his crab dance that has gone viral across social media. Very interesting fact there. Anyway, back to science. His current research focuses on safety and immunogenicity of COVID-19 vaccines, comparing different regimens and routes of vaccination. Antibody responses are analysed using ELISA and plaque reduction neutralization tests, and ELISpot and flow cytometry are also used to observe T-cell phenotypes and their effector function. So Nawamin, thank you so much for speaking to us today, and the title of your talk is Immunogenicity and Safety of Intradermal ChAdOx1 nCoV-19 in the General Population. So over to you, thank you very much.
Thank you so much, Jeremy, for very interesting introduction. So if you may or may not know that actually the past Wednesday is the new episodes of MasterChef coming back again. It's actually brought me back to that horrifying experience, but very exciting as well. And being back to science, so I am a lecturer now at Prince Songkla University in Faculty of Medicine. I have a background in medicines, and I did my PhD, my DPhil in the Jenner with Professor Machen, and then I continue my work on immune responses to vaccinations, which brings to my talk today that I have been doing a lot of research on safety and immunogenicity of intradermal vaccinations. I'm going to present you today on the data that I did with the ChAdOx1 and nCoV-19 in healthy general population. So actually, intradermal vaccination is not new, and this regime this route of vaccination have been performed in many types of vaccines before, such as influenza vaccines, rabies vaccines, and polio, and so on. And comparing with fractional dose and full dose, and it had been shown previously that fractional dose using intradermal vaccination is very good as well. And in my PhD, I actually did the intradermal vaccination using ChAdOx, expressing TB antigens, and I gave it after BCG, which is attenuated pathogens, and I have seen very good antibody and cellular responses. And talking about chimpanzee adenovirus expressing malaria antigens, and they have actually done some research in intradermal vaccinations. And what they found in this study is by giving chimpanzee adenovirus expressing malaria antigens 1/5 of the conventional dose, enhanced very good and very promising antibody responses compared to the conventional intramuscular vaccinations. So I think that by using the Oxford AstraZeneca vaccine would be suitable to give it as a booster. As you may know that in Thailand, we have been using Sinovac, which is the inactivated SARS-CoV-2 as the main vaccines in the past few years. And Sinovac is very good for wild type, but not very good for all the variant of concern, for example, beta and delta strain. So booster dose is actually urgently required for Thai population. So I did a research on intradermal boost using ChAdOx and nCoV-19. I gave it intradermally, comparing with the conventional intramuscular vaccinations. I did collect the blood sample before vaccination, 14 day, 28 day, and 30 day, and 90 days after vaccinations. And we did collect the PBMC to do the T-cell study, and we did collect the serum and plasma to do antibody responses analysis. And we look at the IgG level using ELISA, and we also look at the neutralizing function of the antibody as well using PRNT against Delta strain. And as far as T-cell responses are concerned, we look at the T-cell responses using ELISA on fresh PBMC. And in the frozen PBMC, we did the T-cell analysis using flow cytometry and also peptide from ProImmune as well. And we hope that by doing this research, if we can get some non-inferior arm in this trial, we could give the country some option for the alternative vaccination. So this is the control flow of our study. So we have recruited 100 participants, and we have randomized them into 3 arms. So we have group 1, group 2, group T, group 3, and group 1 is basically the conventional booster arm, which is intramuscular vaccination using full dose of the AstraZeneca vaccines. And the second group is the intradermal vaccination using 1/5 of the dose of the vaccines. And the third group is the intradermal vaccination using 1/5 of the dose of the vaccine again, but the interval between group 1, group 2, and group T is different. The interval of group 1, group 2 is the same, which is the conventional interval is 4 to 8 weeks interval. And the group 3 is extended interval, which is 8 to 12 weeks. The interval that I mean is the interval between Sinovac and the ChAdOx. And then we did the analysis to look at the antibody and T-cell responses. Obviously, if we are talking about intradermal vaccination, we have to look at the local reactions. And as we expected, you can see that in the group 2, group 3, which is the intradermal vaccination, we have seen some immediate reaction. So around 10 to 20% of people who have been vaccinated with intradermal AstraZeneca vaccines have shown some local reactions, but that local reaction is very mild and disappear within 7 days. And when we compare with the group 1, which is the intramuscular vaccinations, for the pain is probably still the same, but the local reaction we have seen more in the intradermal groups. However, the reaction size is very minimal, so it's less than 5 centimeters, so it's not very big. So it's probably the size of your thumb. And we look at the systemic reaction as well, and this is very striking. And this is what we actually looking for. And when we compare the side effect, the systemic side effects of the intramuscular injection compared to intradermal injections, intradermal injection can reduce systemic side effects around 10 times. So as you can see here, people who have been vaccinated with intramuscular ChAdOx is have around 40% systemic reactions. But when we give the vaccine intradermally, this reaction reduces to around 4 to 5%. And it's quite good because of, as you know, that a lot of people in Thailand, when they plan to have vaccine, they tell the boss that we're going to have a few days off because we're going to have side effects. But by giving it intradermally, it actually hugely reduce the side effects of the vaccines. And now we look at the antibody responses. And you can see that this is before vaccinations, group 1, group 2, and group T. And interestingly, before giving the vaccine in group 3, which is in the extended interval around 8 to 12 weeks after Sinovac, the antibody response is slightly less compared to the conventional interval, which is 4 to 8 weeks. And then when we gave the vaccines intradermally here and intramuscularly here, you can see that the antibody responses at day 14 is comparable. Slightly less, but it's comparable. But when we look at it in day 28, you can see that the antibody responses when we give it intradermally, it's slightly less, around around 20 or 30% less compared to conventional vaccinations. But when we're looking at the neutralizing function, using PRNT against Delta strain, for the conventional booster, which is the intramuscular AstraZeneca vaccines, the neutralizing is around 300, and then when we compare to the intradermal vaccination, is around 200 something. So it's not too bad when you look compared to the conventional vaccination. We gave the vaccine 1/5, so basically 20%, but the response that we gain is around 80% compared to the conventional booster. Now we're looking at the T-cell responses. As you can see that for the T-cell responses, it's again comparable at day 14, but when we looked at day 28, the intradermal vaccination here is not actually inferior at all compared to the conventional booster. But when you look at the extended interval, so 2 doses of Sinovac, and we let the participants for around 8 to 12 weeks, and we gave another booster with intradermal ChAdOx. The response is slightly less, so it's not as good compared to the conventional interval, which is 4 to 8 weeks interval. And now we did the flow cytometry to look at the deep T-cell analysis, and we used obviously peptide from ProImmune. We use S1 peptide, and we look at the T-cell responses, and we did the surface and also intracellular staining. As you can see here, we look at the interferon gamma secreted CD8 positive T cells. At day 0, you can see that the response is slightly less, already less in the extended interval group. Again, day 14, they look the same. And but when look at the day 28, the intramuscular booster compared to intradermal booster is seem to be comparable. But when we look at the extended interval of the intradermal booster, the response is slightly less. And the TNF alpha cytokine producing cell following the same trend with the interferon gamma. As far as the CD4 responses are concerned, we also look at the cytokine producing CD4 positive T cells, and the data is showing a similar trend with the CD8 responses. Again, we can see that the day 14 looks very similar, but on day 28, the extended interval have slightly less response compared to the conventional interval booster, which is 4 to 8 weeks. And again, the TNF alpha responses following the same trend with the interferon gamma responses. We bring you to the summary, which is the immediate and the delayed local reaction were frequently observed in the fractional intradermal boost, but it's a big but. The systemic side effects were significantly decreased when we compare to the conventional intramuscular boost, which is very good for people because they don't want to get sick after the vaccination. And then when we looked at the antibody responses, neutralizing function of the antibody against Delta strain, T-cell responses, the significant increase after boosting with both routes of vaccination. So intramuscular and intradermal seem to be induced very similar immune responses. Interestingly, very interesting, which is the shorter interval can enhance higher immunogenicity compared to the extended interval, because as immunologists, we think that the longer interval you leave might enhance better immune responses, but it's not in this case. And now we look at the reciprocal dose of the intradermal of the ChAdOx, and this booster dose is enhanced non-inferior humoral and cellular responses when we compare with the full dose intramuscular boosting. And this finding actually provide an effective vaccine management during the shortage of the vaccine supply. And we actually have done this in the Phuket sandbox. If some of you might have been in Thailand, that we have applied this into Phuket because of all the people who work in the hotel industry, they need a booster dose before we open the country. And we have done the intradermal injection using the ChAdOx vaccines. And we enhance very good antibody responses, and we can open the country to welcome all the tourists to experience a beach holiday in Thailand. And obviously, I can't do this alone. I have my lovely groups here, which is my master's students, Pulilab, and we have Jom Kwan, Rachanon, and Banya, which is my lovely research assistants. We have a lovely co-PI as well, and we have the grant support from my universities, national vaccine institutions, and also National Research Council of Thailand. And we have the Clinical Research Center in my hospital to help to conduct the trial. Thank you so much. And I'm going to open for all the questions that you have. Thank you.
Thank you so much, Nawamin. That's great. I really appreciate your talk, and we're looking forward to now going to Thailand on our holidays.
Please.
With all the vaccinated tourism workers. Fantastic. Great. We have a question from Path, is asking, in the ELISpot that you did, was that ex vivo ELISpot or were the T cells cultured?
So it's ex vivo ELISpot. So I used fresh PBMC from our participants who have been vaccinated with the vaccines, and we did the ELISpot straight away. And left over PBMC, we frozen this PBMC and did the flowcytometry after.
Great, thank you. Perfect. Any additional questions at all for Nawamin? Please just you can either raise your hand, and I should be able to hopefully see you. Emily, if you want, actually, Nawamin, if you can stop sharing, that would be great. Then I can probably see
yeah, sure.
hands that pop up, if there are any. Thank you. Great. So maybe one question. Actually, done a lot of work there with looking at the T cell responses using ELISpot and other flow cytometry phenotypic analysis. Do you also have plans to look at sort of antigen-specific responses with multimers? Was there a particular challenge with HLA typing? Do you have that data, or is that kind of the main thing that's holding things back?
Well, I'm actually planning to do, I love tetramer staining. I did that in my PhD, it's great. And we're planning to expand our work on that as well. But it's actually tricky for the vaccine trial because we have a lot of participants and we have a lot of samples, and tetramer is pricey. So we want to use it in a good, the sample that we think it fits. So we actually planning to introduce tetramer staining in our lab and look at the immune responses to other vaccine regimes or against other variant of concern as well. It's very trendy, and we're actually looking at it.
That sounds good. So do you have a particular strategy in place to then select exactly which donors you would want to focus that kind of analysis on? Is it going to be if they have a particular characterization of the phenotypic analysis, and then you would, or obviously you need enough cells, but also just to, what's your strategy there?
So, well, I'm actually planning to do, well, I got the peptide from you, and I'm going to do the epitope mappings myself, and to see that which of the peptide sequence is the immunodominant, and then we probably going to select a pool and since the tetramer, because of it's a bit tricky to find the, because we have, well, in Thailand no one has done the epitope mapping using this even the wild type S1 or S2 peptide yet. So we want to have that done properly, and then after we have the good set of the pool S2, and we're going to get the tetramer in and doing the staining.
Great. Well, hopefully we can help you out with that. Then we'll look forward to collaborating with you on that. Fantastic, super. Okay, well, thanks again, Nawamin. I don't think we have any more questions at the moment, so we will move on to our next speaker. But again, thank you very much for your presentation.
Thank you. Thank you. ขอบคุณครับ